Hello and welcome to the second coding session regarding the encoder module. Today we'll be hopefully building our encoder as independent modules that we can embed within our PyTorch template, specifically the dataset module within the PyTorch template. So we are going to build it step by step here, as we have already built the core functionalities. So we're just going to make it as a class and use it to return the encoded part and padding within such a module. Okay, so I've here added some illustrative questions that you might be asking yourself, why this needed, why this needed. So I have here worked through this part, so you can be checking such questions anytime you are wondering or after you have passing through this notebook. I've also shared it on the GitHub repo, so you can open it and stop the video for now and try to solve this from your side. After this, you can watch my video. If you need any support, I will be tagging each part of the video, so you can move smoothly across the video, across the solutions through the video. Okay, so this is the encoder. This is more or less we have discussed, we have already built, implemented through the previous lecture. Okay, the only added functionality here is the encode plus and the decode. Of course, the encode plus will be the same as the encode, but it just applies the pre-processing and encode into indices, and after this pad or truncate this this text, because this text will be a human written review. Any review can be, and this encode plus is our you can say the API or the representative of our module in the encoder module, because this will be used within the PyTorch module. So because this function will be combining all the pre-processing tasks, still the encoding and padding and truncation of the user review. Okay, after this the decoding will be used, but it will not be needed, but we will be developing it as well. And this is the call method, which will be initializing all such pre-processing. And then here we will be reading our data. I have download this data from the Kaggle platform, so you can download it as well from your site. Okay, so let's get started. I will be importing the packages, and I will be starting with this data. I will be reading this data set, and here, as you can see, we need to apply pre-processing task. So first I will show you what is the data set about. As we have discussed through the theoretical lecture, we will just need the score and the text here. Okay, so in that case we will be selecting such two parts, such two columns, and also have find out that there exist a lot of duplicates, so we need to drop the duplicates as well, and also to reset the index. Okay, so this will be, sorry for that, this will be our clean version of the set. I can see it again in this part. Okay, and the shape will be 300 across 400 review. Okay, so now we have this text here. So this is our corpus from our last video. This is the corpus now. It is just a little bit bigger, and here we need to decide what is the max length that will be needed for the encoder to start with. Okay, so actually we need to build this plot here. What is this plot about? this will be the distribution of the token across distribution to the number of tokens across each review. Okay, so for example here this token distribution is of course right skewed, and you can see here if we have a threshold, so we can put this threshold, like for example this is there exists a lot of reviews with the number of tokens of it is within the 25 or within the 30. Okay, but if we have truncated the if we have set the threshold to this part, this will be truncating all these reviews, because there exists a lot of reviews also beyond the 30 token. So we need to have some threshold which can be statistical chosen regarding, for example, if I have using the describe here to determine what is the meaningful number to set as a threshold for the number of tokens for each review. And here, for example, like I've chosen the median. Okay, and this is 57. So if you can see 57 here is pretty much in the middle of this distribution. So in that case, we can use it as a token threshold. After we use this, we will be building the encoder module and using the encode plus, because this is, as you have mentioned, this is the interface of or the API for our module, and inserting it to any text. So the output should be an encoded array. And here, if we need to use the decode, we take this encoded format of the text and decode it. Okay, so this is the objective of this notebook. So let's start with using the distribution of the tokens. So basically we will be tokenizing our text, but we will just use the split the string split method as our tokenizer for now. But of course we can add more cleaning or pre-processing to such a module, but we just need to make it as easy as possible. So let's split each so if we have to split it here like this, I'll just show you it step by step. For that, okay, so here you can I have selected just the first 5 text, and then splitting each of which, as you can see here, but I need the length of these tokens, so I need to apply len as our function. So here we can see like we have 48 token, we have 31 token actually. So let's put this as here text length in a new column called text length, and of course remove this head. Okay, as you can see here, if I just use this plot for these tokens, it is a lot of skewness with this distribution. So what I have done here, I have reduced this focused only on this part, and remove it by filtering anything beyond this quantile of 90. Okay, and showing the distribution as you can see here. So as you can see here, it is pretty much focusing on this main distribution, because these are outliers, of course. Like some reviews have 3000 tokens, so these reviews are outlier to our model, so we don't need such much of data, and of course we don't need less than Like for example, the minimum here is 3 tokens. Okay, we can also filter this as well, but we don't care about this for the right time, for the meantime. Okay, so for example, here we have decided the Max-Len as our median of the distribution, and we can run our encoder as this. So it takes this text pandas series. Like for example, it takes text, and it will be taking, because this is our corpus, as you can see, this is our corpus of the data, and it needs the Max-Len. Okay, so let's start to build this step by step as we have mentioned. Okay, so first thing we need to do is the vocab creation, and here we should be giving tokenized series create from the call. So the pipeline here is defined within this code method. So we need first to build the vocab, and then the word to index, and then the index to word. Why we need to build these two dictionaries? Because this will be needed for the encoding method, and this will be needed for the decoding method. I also have mentioned such questions within the illustrative part below, aforementioned below. Okay, so first thing we need to sorry for that, we need to tokenize our series. Okay, so we need we have this text token series, and we need to apply such a pre-processing parts upon it. So for example, here I have created another module called the utilization, and this is nothing but a helper method, a helper script that will be used for writing our helper methods, right? For example, the stemmer, the build, the limitizer, stop words to remove the stop words, etc. So for example, here we have a list of methods that we need to apply for each review. For each review, we need to make it in a lowercase, we need to tokenize it, we need to remove the stop words, and we need to apply stemming upon it. So let's start with developing this module. So to lower, just we need to insert it lower, and tokenize, we need to make it in a split. Of course, we can add a lot of stuff, but we just need to make it in this simple way. Okay, and then we need to remove the stop words. Okay, so here we need to remove the stop words. So in that case, we need to split, because the review token now is being splitted, so it will be a list of tokens, and we need to check whether there exists anything from these stop words or not. Okay, and the stop words here is defined, as you can see, within this part. It is imported from this NLTK library, and we just took the English stop words and excluded from the stop words anything with not. Okay, because the not is important for our task, because we care about the sentiment. So if the food is not good and the food is good, will be the same if we didn't exclude such a point here. So it not is important or a core keyword to our task. So we need to first check these review tokens, whether any token is within these stop words. Okay, so like here for token or token in review tokens, if token is not in English stop word. Sorry, this is not. if token not in English tables. So just simple as this. And then we apply stemming, so it is much easier, like as we have discussed earlier. We are going to stem the token for token in text tokens. Okay, and this is a pipeline method, which will be instead of making this in such hierarchy like this, I need to work in that way. So we have here to take an input as a list of functions, and this is the text that we need to apply or transform. So basically we would be looping through each function and applying such a function to the X, and also it will be returning another transformed output, but we need to make it again inserted to the next function, transforming function. So we need also to make it as X again, and it will be keeping transforming such X until all this list of functions, which is defined in this pipeline, being applied. So this is the final method, the pre-process review. We can save it here, and let's go back to our model. And for example, if I restart our notebook to be aligned with the pre-process review method. Okay, and let's start again with our data. Let's remove this, and here we remove the duplicates. We check this, and let's start to apply this pre-processing data. And here we check the text and also the first 5 lines only, and we can pre-process the review such like this. Okay, so as you can see here, this is the clean version of this part. Okay, I have put several of the vital, so I have been dropped because it's a stop word of as you can see, several of the volatility canned dog food products is several have been truncated into severe. Okay, it is not severe like the word severe, but it will be a little bit incorrect stemming. So the stemming, as you can see, is can produce incorrect output, but it's pretty fast. So that's why I have used it, because it's might be better to use a lemmatization in that case. But as you can see, we need to make it more simpler, because we will be by the end of the day using a pretty much already built tokenizer from the Hugging Face library. So we don't need to bother a lot with this stuff. Okay, so this will be the apply pre-processing. We will be returning this list of tokenized part, as you can see here. So for example, we need to apply to our text column. If I just concatenate all these methods, and here we have this series, panda series, and we need to apply this pre-processing. So we apply to it this review pre-process review method, such like this. Okay, and then we will be creating the vocab. So we'll call it as self-create vocab. Okay, and after this we'll be building this word to index. So create a word to index and create index to word. So let's start with the creation of the vocabulary. As you can see here, we need to first flatten all our tokens in a single list, and then giving each token an ID, and of course adding the padding and the unknown token through our dictionary. Okay. As you can see, I have mentioned here these notes as well, so you can read it while you are developing. So in that case, we have this text tokenized series, and we need to apply for it this flattening. So for example, here, if I took this as our testing part, and we need to check this, like this will be text tokenized. Okay, this will be just working on, and then we'll be copy pasting it in our module again. So we just need the values, and we need to chain this into a set. Okay, so this will be our tokens, as you can see. So let's go back to our vocab, and we will be applying this as is. We'll be taking these such values, and but of course here we applied the pre-processing to our reviews. So if we need to apply this, okay, yeah, we can also have another tokenizer, like without apart from the split, to remove this such double quotes and dashes, etc., and symbols. But as you can see, we need to make it as simple as possible. Okay, so here will be the tokens, the wool tokens. And here we need to add for it first we need to add two dictionaries, one for the unknown and padding, and another one will be for the tokens, giving it index, and we're appending them and call it in the vocab. So let's start with the next one. It will be token. Okay, and index for index token in enumerate tokens. Okay, because this will be not the vocab, this will be a dictionary that will be used inside this create word topic. So here we need to, the vocab will not be a dictionary, it will be a list, as you can see. So sorry for that. We will be appending to this list of tokens, we'll be transforming it to a list. So this will be the vocab, more or less, or the tokens, as you can see. Let's see when we'll be using this. Okay. Okay. Exactly. So in that case, we'll be just having this list of tokens as vocab. So you can just rename this as self of vocab, while this will be used inside the create word to index. Okay, So what will be here adding, we need to add this part here. So first we have a module called constant inside this utilized helper method. Constant here will be having this padding value and O of V out of vocab value, and the padding and the out of vocab index, padding index and out of vocab index. We'll be using this as here. Padding value will be mapping to the padding index, and the OOV value will be mapping to the OOV index. And we will be here enumerating across the vocab just like this, and the other part will be the same unless, which will be the index to word, but it will be the inverse. So instead of padding value here, I can just multi-select it in such way, and let's make it an index, while here for index it will be val. Okay, sorry for that, I think it is messed. Okay, for the index this will be val. Okay, after this will be also transforming this into the reversed way. Okay, so this will be the two dictionaries that we are going to use across our methods. After this, we need to pad and truncate, and first we need to encode using this word to index dictionary. So we will having this text indices, text tokens, and we need to give them an index. So we just need to use this index to word as our dictionary. So we need to use it here like this, and for token and for token in text tokens, and this will be a list of integers, and we should get here if it is not exist within our corpus, we need to out of a value out of value val. We need to use this actually, not the index to word, but the word to index, because we need to return an index and take a word. Okay, this is the encode, while the encode plus will be applying everything from scratch. We will not be depending on this call method actually, but we'll just be applying everything from scratch. So we need to first apply this pre-processing. So we need to pre-process the review, and then we need to this will be returning a list of tokens. Okay, and then we need to encode this using self.encode to call the encode method, and then we need to apply padding to this. So this will be actually the full pipeline will be applied to this list of tokens. Okay, and of course we need to add the maximum length to our padding part. It will be the final objective of our module. The encoder will be as simple as the decode. The decoder will be as simple as the encoder, but we just use this in the reversed way. Like here, for example, I will be just collapsing it, and here will be returning this. Will not be the tokens, but it will be the text decoded for example, and we'll be using the index to word to get token index, and we'll be checking the OOV index if it doesn't exist, and here we'll be taking the token indices. Okay, here we are going to return it in a clean version, so we don't need to see within our output multiple 0000 by the end of our token. So we need to clean it, so we will be just returning as this. We'll be looping through these text tokens now in text decoded. If these tokens not in, okay, it will be a token, not tokens, sorry for that, not in c dot ov val or c dot padding val. So we don't need to see padding by that extension of our token. We just care about our actual tokens. Okay, sorry. And here we will be, if we need to see these special tokens, then we just return this decoding of these tokens out of value. The last part here to apply is the padding truncate. So we need to apply padding here. As we have discussed later, we have this nb.pad, and it takes a list array, first array, then we have this before and after. It will be max length minus the length of the text indices, and here the constant values will be the value of the padding. Okay, because this will be used for the encoding, so we need the index of the padding. Okay, because this is the padding, but basically this will be used if the max length is greater than the length of the text. But if it is less than the text indices, as we have discussed earlier, there exists an error which will be returned from the padding numpy method. So we just need to truncate it in such a way to the max length. Okay, and return the truncated version of our text indices. Okay, so that's pretty much what we are going to do within our module today. So let's run it and see whether it works fine or something need to be applied. So let's start from the beginning. We read the data. We will be calling, remove this tasks because it will not be needed after all. And here we have decided what will be the max length. It will be 57. Okay, so I can also run this part and remove this. So let's call the encoder module for now and see what is the result. It will take some time. Now it's pre-processing our views. Okay, and it will be creating the two dictionaries as well and the vocab list. And also we can access any input from this module within this using this encoder instance. Okay, I think it's taking a lot of time. Let's see. Because more or less our helper methods, as you can see here, are pretty much might be taking much time regarding this um, stemming stopwords. So that's why I've actually used this stemming only. We're not using the lemmatization because it will be much more time. Okay, the time complexity will be increasing as we increase each searching or something like this. So I need to make it a little bit similar. So as you can see here, if you build an encoder from scratch, it will be taking much time. So that's why we'll be first we'll be using some Hugging Face encoders. So right to make it working as well in a more fast way, because the tokenizers from Hugging Face will be much fast and using a huge vocab. So we will be using this by the end. And for example, here we have torch text and spacey, TensorFlow, and transformers. These are all frameworks that we can use as a tokenizers. But for the next part, we'll be embedding our encoder module here that we have inside our deep learning model that we are going to build through the next lecture. So the next lecture will be focusing on building that PyTorch template, okay, and building each module within it, like the dataset, the model, and the engine. Also the train script, which will be combining all these modules as we have discussed earlier. And after this, we will be embedding our encoder inside our dataset module of the PyTorch template. Okay, I think it will be taking much time, so you can run it also from your side and apply this encoding. It will be returning such an array which will be removing each token and using this returning the index of it, and then it will be decoding it using this decode method, using the clinical true to remove any OOV or padding. Like it will be returning every zero here will be padding. So that's why I have cleaned it to filter this padding indices. Okay, I hope you understand today's lecture and see you there. Bye.